which will involve some problems of alike objects that we have already completed in the previous lecture, but in this tutorial also we will do some problems which are little critical. And then we will go for palindromic number, then we will move for circular permutation, and last but not the least, we will complete the rank of a word in the dictionary. So be ready and fasten your seatbelt because today's class is going to be a wonderful one. Bang on to the class directly. In this question they have said that find the number of 7-digit integers, 7-digit, such that the sum of the digits is 59. Clear? So you have to find out how many number of 7-digit integers are there when the sum of the digits you have used is equals to 59. Now look it very carefully. Suppose if I put all those digits as 9. So there are 7 9s. So if you add all the digits, you are going to have 9 into 7, 63. But you have to use those digits whose sum will be equals to 59. So we can easily see that it is very close to 63. So maximum number of 9s will be there in the number so formed. So let us now take case 1. Let me say all the 6 digits are 9. All the 6 digits are 9. So what will be the 7th digit? 9 6 are 54. So we are left with the digit 5. So let me just place this place by 5. Yes or no? So if this place is filled with 5, then you add all these numbers, you are going to get 59. So how many such numbers that can be formed? Simply arrange all those digits in the 7 places. So that can be done in factorial 7 divided by factorial 6, which is equals to 7 different ways. Because 6 9s are identical, that is why I have divided by factorial 6. Now let us consider case 2. What is that? Again, the 5 digits are all 9. Now let me take out one from this 9 and give it to here. So it will become 8 and this one will become 6. Am I correct? Again, the sum of all the digits is again coming to 59. So what will be the total numbers so formed by all these 7 digits? It will be factorial 7 divided by factorial 5. Why? Because 5 9s are identical. So total number of such digits that will be formed is 7 into 6, that is 42. Am I correct? Now, case 3. What are the other possibilities? Let the 5 places be filled with 9 and let me take out 1 from here and add it here. So we are getting 7 here and 7 here. Again, the sum of all the digits is 59. And now these digits can arrange among themselves in factorial 7 divided by factorial 5 into factorial 2. Why? Because 5 9s are identical and 2 7s are identical. Therefore, if we calculate this, what we are going to have? 7 into 6 into factorial 5 divided by factorial 5 into 2. So this gives us 21. Is it clear? Now what are the other case? Case 4. Now let me write 9 fours and take out 1 from this 9 and give it to here. So this digit will become 8, this digit will become 8 and this remains same as 7. So the total number of such numbers so formed will be factorial 7 divided by factorial 4 into factorial 2. Why factorial 4? Because for 4 9 identicals and 2 identical 8s, we have divided by factorial 2. So the answer is coming to 7 into 6 into 5 into factorial 4 divided by factorial 4 into factorial 2. So factorial 4 goes off, 2 goes off this thing with 3. So it's 7 into 15. So that gives us 105. Am I correct? So these are the case 4. Now any more case? Yes. One more case can obtain. That is, if these places are 3 9s and take out 1 from this 9 and give it here. So this one will become 8. This is again 8, 8, and the last digit will be 8. Clear? So the 7 places can arrange among themselves. Factorial 7 divided by factorial 3 into factorial 4. Factorial 3 is for 3 identical 9s and factorial 4 is for 4 identical 8s. So you are going to have 7 into 6 into 5 into factorial 4 divided by 6 into factorial 4. This goes off, 6 goes off. So it is coming to 35. Am I correct or not? So now you see, there are no more cases which can be formed such that if you add all the digits of this 7-digit number, it will give us 59. It's not possible. Why? Because if you want to take 1 from here and add it here, so it will become what? 9, 9. This one will become 8. This is 9. This is 8, 8, 8. And this case is same as this case. Because we have arranged all those digits in the 7 places in 35 different ways, in which one form is this, because it also contains 3 9s and 4 8s. So there will be no more cases which can be formed such that the sum of the 7-digit numbers, if you add the 7 digit of this 7-digit number, it will give us 59. So the total number of ways will be 7 plus 42 plus 21 plus 105 plus 35. So that gives us how much? This is 49 plus 21, 140. This is coming to 70. And this is 140. So answer is 210. So 210 such numbers are there. Numbers means 7-digit number are there such that the sum of the digits will be equals to 59. Have you understood the approach of this sum? Always start with the maximum number. And then you see how much less is the number which if you add all the digits you are getting. So accordingly you manipulate, you reduce 1, you increase 1, you reduce 1, you increase 1, and this way you go. Because one thing for sure, maximum number of 9s will be there. As 59 is very, very close to 63. And 63 is the sum of all the digits. If all the digits are 9, the sum will be 63. So our the numbers that will be formed will contain maximum number of 9s. So you have to start your problem, you have to approach your problem from that point, and you have to proceed in this way. Is it clear to everyone? Okay, let's move for the next problem. Answer is 210. Wow, this question is a fantastic sum. See this question, what they have said. Consider the grid as shown in this figure. A person starts from A. A person starts his journey from this point A and wants to reach at B. And he can only move along the border either up or right. This is up and this is your right. So a person can move along the border either up or right. He cannot move left or he cannot move down. Okay? In how many different ways, the first question, in how many different ways he can reach from point A to point B? Wonderful question. Now, if you start on calculating, first thing, it's impossible to calculate manually. You cannot count how many number of ways are there to reach from A to B. So definitely, we have to use some intelligent process here. Now see, what I'm saying is, to reach from point A to point B, you choose any path you want. Either you move up or you move right, but you choose any path accordingly so that you can reach at B. Let me take the easy part. Let us say the person moves like this, then this, then this, this, like this way. He is moving till this, and then again he is moving up and he is reaching here. So how many, suppose if he moves in the crossing without crossing D, that can be one option. He is reaching from A to C, then he is reaching at B, and he crosses the point D. That can be another option. Or it can be like this, that A is reaching directly to D without crossing point C. That can be another option. So these are the 4 options that are available to us if the person wants to reach from point A to point B, and whatever condition is given that he can move only up and right. Okay, so these are the only conditions. Now the question is, he never crosses C and D. So let me just do one thing. Let us try to find out in how many different ways the person can reach from A to C, then from C to D, and then from D to B. From A to C, there are how many different ways? 1, 2, 3 right and 2 up. 3 right and 2 up. So the person can reach from A to C in how many different ways? Factorial 5 divided by factorial 3 into factorial 2. Is it clear? The person reaches from A to C. Now you tell me, in how many different ways the person can reach from C to D? From C to D, there are 1, 2, 3 right movement and 2 up movement. So it can be arranged among themselves in how many different ways? Factorial 5 divided by, again factorial 3 into factorial 2. So now the person has reached to D from C. In how many different ways? This is the total number of ways. Now from D, in how many different ways he can reach to B? There are 3 right movements and 1 up movement. So it can be arranged among themselves in factorial 4 divided by factorial 3. So the total number of ways in which the person can reach from A to B, crossing C and D, is nothing but, I'm writing it here, it's nothing but factorial 5 by factorial 3 into factorial 2. This one I have taken. Now you take this one. And then you have to take this one. So this is what? This is the total number of ways in which the person is reaching from A to B via C and D. Now, without any restriction, in how many different ways the person can reach from A to B? It is this one. This is the answer which we got from the first question. Therefore, the total number of ways in which the person will not cross C and D will be this minus whatever we got. Yes or no? Tell me yes or no. What I have done, first I found, already we have done it in question number 1, that is without any restriction in how many different ways the person can reach from A to B. Now we have subtracted the total number of ways in which the person will reach from A to B via C and D. So, the answer that we are going to get after subtracting is what? The person is reaching from A to B, but not crossing C and D. It can come from A to C, then from C to B, no problem. It can come A to D, then from D to B he is reaching, no problem. But he is not crossing C and D simultaneously to reach at the point B. Is it clear to all? Absolutely, it's a fantastic sum. You have to understand the logic behind it. Okay? Let us take the next problem. So this question. Consider the grid as shown in the figure. In how many different ways a person can reach from point A to point B, which is shortest. Again, a very important word they have used. Shortest. Shortest means a person can either move up or can go right. Neither he will go left nor he will go down. Because you see, from this point A, if you want to reach, let us say point C, the easiest way is, and the shortest way is, you go right, then up, then right, then up, then right. It's okay. This is the shortest. Why I'm saying shortest? I'm showing you. Now suppose if I say the person goes like this. First this, then he goes this, then he again go to the left, then again up, then again right, then again down, then again right, then again right, then again up. Now is this the shortest path? No. So whenever, they will never say you that the person is moving up and right. They will never say that. What they will say, find out the shortest distance. Now you have to understand, the shortest means the person is starting from A. He can either move up or he can go right. Neither he will go down nor he will go left. Is it clear? Okay. Now the question is, find out the shortest distance from A to C. In how many different ways the person can reach. Now, one thing is very sure to us, that I have to reach point C. Why? Because from point C to point D, there is only one path. Now, if you want to go in some other way, you have to travel more than one path to reach point D. Even if you don't cross the point C, that will be not the shortest one. Because at any point of time, you have to cross more than one path. But if you reach at C, then at D, from C to D, there is only one path. And to find out the shortest distance, we should take advantage of this path. Then only the path will be the shortest one. Is it clear? So in how many different ways the person can reach from A to C? There will be 1, 2, 3 right movement, and there will be 2 up movement. So this 5 ways can be arranged among themselves in factorial 5 divided by factorial 3 into factorial 2 different ways. Is it clear? So now the person has reached from A to C. Now from C to D, there is only one path. That is the shortest one. Is it clear? Now from D, he will reach at B. In how many different, the path he has to take? Right, 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 and then one up. So 3 right and 1 up, which can be arranged among themselves in factorial 4 divided by factorial 3 ways. Again, I'm not going for the calculation. Calculation, you can check it. So this will be the total number of ways a person can reach from A to B. And if the path is shortest, he has to travel via C and D. Is this clear to everyone? Absolutely clear. So the total number of ways in this case will be this one. This is the total number of shortest path traveled by the person to reach to B from A. right? Okay, so I hope this kind of problems you can handle with, right? Now let us go for the next conception. So now let us start with what is palindrome number or palindrome word. Palindromic number means if you write a number and then you reverse the number, you are going to get exactly the same number. Same thing with the word. In any word, if you reverse the word, you are going to have the same word again. So this kind of numbers and words are what called your palindrome number or palindrome word. Is it clear? Like, let me take an example, like say 2, 3, 4, 3, 2. It's a palindromic number because if you reverse it, you are going to get exactly the same number. Similarly, if we take a palindromic word like madam, and if you reverse this word, you are going to have the same word madam. So this is a palindromic number and this is a palindromic word. Is it clear to all? Have you understood what is a palindrome? Like, one very interesting thing you can observe here that in a palindromic number, this place and this place, they are same. This place and this place, they are same. All the digits in those places are same. In case of palindromic word also, this place, the first place and the last place, again this place and this place, they are all same. Is it clear? So this is what is called your palindromic number. Now, since we have got one thing, now we have to apply mathematics in it. Let's see. Let us say, find the number of 8-digit palindrome number. You have to form 8-digit palindrome number. And how many such numbers are there? So 8-digit palindrome number means 1, 2, 3, 4, 5, 6, 7, 8. Now, whenever you are constructing any palindrome number, you always start from the last digit and think in how many different ways this place can be filled. Now somebody can say in a hurry that, sir, this place will be filled in 10 different ways. Wrong. Because this place cannot be filled with 0. Why you know? Because whatever digit you are putting here, you have to put the same digit over here. And if it ends with 0, it means the digit will start with 0 since it's a palindrome number. And which is not possible because if the 8-digit number starts with 0, it no more remains a 8-digit number. It becomes a 7-digit number. So be very careful while you are filling the last place. So the last place will not be filled by 10 different ways. Rather, it will be filled by 9 different ways. Any of the 9 digits can be used here. 0 is not included. I have explained why it is so. So any 9 digits can fill the last place of 8-digit palindromic number, right? Okay, so if this place is filled in 9 different ways, obviously this first place will be filled in only one way. Can you tell me why? Because whatever number you are putting at last, the same digit you have to put at first. Because again, it's a palindrome number. Clear? Again, this place now can be filled in any of the 10 digits. Now 0 can come, I don't mind. So this place can be filled in 10 different ways. The moment the digit comes to this place, the same digit has to repeat in this place. Therefore, this place will be filled in only one way. Because whatever digit you are putting here, you are putting exactly the same digit over here. So if this place can be filled in 10 different ways, this place can be filled in only one different way. Are you getting the point? Whatever digit you are putting here, you are putting the same digit over here. Okay, so the next digit again will be filled in 10 different ways. Similarly, this place can be filled in only one different way. This place again can be filled in 10 different ways. And this place can only be filled in one different way. Therefore, total number of 6-digit palindrome number that can be formed is 10 into 10 into 10 into 9. That gives us 9,000 such palindromic numbers are there, which are an 8-digit number. Is it clear to everyone? Absolutely. Have you understood how I'm finding out the number of palindromic numbers? Clear? Let's take another example. Find the number of 7-digit palindrome number. 7-digit. 1, 2, 3, 4, 5, 6, and 7. So this place can be filled in, by the same argument, this place can be filled in 9 different ways. 0 cannot come. So this place can be filled in only one different way. This place, I don't have any objection even if 0 comes. So this place can be filled in 10 different ways. So this place can be filled in one different way. This place can be filled in 10 different ways again. This place will be filled in only one different way. Because whatever number you are putting here, you are putting the same digit here. Now, this place can be filled in 10 different ways. Therefore, total number of 7-digit palindrome number that can be formed is 10 into 10 into 10 into 9, which again gives us 9,000. Is it clear or not? Have you understood this? See, first I have formed a palindrome number, even digit palindrome number. That is, we have found 8-digit palindrome number. In the second case, we found the odd digit palindrome number. That is 7-digit palindrome number. So now you are comfortable of forming palindromic number which are even odd or even, doesn't matter. Okay? Let us take the next example. Now the question is, find the number of palindrome numbers less than 10 to the power 5. 10 to the power 5. So it's a 6-digit number. So all the numbers which are less than this will be either 5-digit, or it can be 4-digit, or it can be 3-digit, or it can be 2-digit, or it can be 1-digit number. So we have to find out all the palindrome numbers which are less than 10 to the power 5. That is all the numbers, all the palindrome numbers which are of 5-digit, 4-digit, 3-digit, 2-digit and 1-digit. Now 1-digit palindrome number will be only 10 ways are there. Am I correct? Absolutely wrong. Because this place cannot be 0. 0 is not any digit number. Can you say it's a 1-digit number? No. So this place can be filled in only 9 different ways. So 1-digit palindromic numbers are how many? There are 9. 2-digit palindromic number. This place can be filled in 9 different ways. Again, this place can be filled in only 1 different ways. Therefore, total number of 2-digit palindrome number will be 9 into 1. That gives us 9. 3-digit palindrome number. This place can be filled in 9 different ways. This place can be filled in only 1 different way. Because whatever digit you are writing here, you have to write the same digit here. And this place there is no restriction. Any of the 10 digits can come. Therefore, 3-digit palindromic number will be 10 into 9, which gives us 90. Clear? Now let us consider 4-digit palindromic number. Let me do it here. 4-digit palindromic number. So this place again can be filled in 9 different ways. Same digit will come here, so it will be filled in 1 different way. This place can be filled in 10 different ways. And this place again can be filled with the same number what is placed here in 1 different way. Therefore, 4-digit palindromic numbers are 9 into 10. That gives us 90 again. Is it clear? Now let us come for the 5-digit palindromic number. This place can be filled in 9 different ways. In the similar way, this place can be filled in only 1 different way. This place can be filled in 10 different ways because here now 0 can come. This place will be the same digit what is placed here, will be in 1 different way. And this place again there is no restriction, so 10 digits can come here. Therefore 5-digit palindromic number that will be formed is 10 into 10 into 9, that gives us 900. Therefore total number of palindrome numbers which are less than 10 to the power 5 will be 900 plus 90 plus 90 plus 9 plus 9. So that gives us how much? 900, 180 and then 18. So it's 891098. So how many number of palindrome numbers are there which are less than 10 to the power 5? It is 1098. Have you understood? So if they ask you how many number of palindrome numbers are there below this number, so you have to consider all the cases. Here there was 6-digit number because 10 to the power 5 is 6-digit number. So it's not that they are asking you find out the number of palindrome numbers which are of 5-digit. No. They are saying find out all the numbers which are less than 10 to the power 5. Means 5-digit, 4-digit, 3-digit, 2-digit and 1-digit palindrome number we have to take into consideration. Is it clear to everyone? Have you understood this? Let us take another problem. Now there is a little twist. Find all palindrome number of 5 digits which are divisible by 4. Now, there is a little trick. It's not trick. We all know this. See, first thing you should know that for a 5-digit number, how you will say that a number is divisible by 4? Class 7. Remember class 7. What they say? If the last 2 digits are divisible by 4, then you can easily say that the whole number is divisible by 4. That's it. So same logic I am going to apply here. So first I will choose in how many different ways the last 2 places of this 5-digit number can be filled such that it is divisible by 4. Now, I can say that these 2 places will be filled with the numbers which are divisible by 4. That is, it will be of the form 4k. So now your k can take the value, think about it, your k can take the value 0, 1, 2, 3 and this thing goes on till how much? Till 24. Because the maximum 2-digit number which is divisible by 4 is 96. 2-digit number. It's 96. So the value of k can be taken final value. I mean the maximum value that k can take is 24. Now you see, look it very carefully. If k is 0, then the last 2 places is what? It's 0. That is, the last 2 places will be filled with the number 0, 0, which is not accepted. Which is not accepted. Why? Because the last digit cannot be 0. Last digit cannot be 0. So k cannot take the value 0. Well, if k takes 1, the value of 4k will become 4. That is, the last 2 places will be filled with 0, 4. That is accepted. If k takes 2, it will be 0, 8 and so on so forth. Till k is 24, the last 2 digits will be 96. All are divisible by 4. So how many such numbers are there? 24 such numbers are there. But there is a problem. The problem is, suppose if k takes the value 5. If k takes the value 5, then what will be the last 2 digit? The last 2 digit will be 20, which is again not accepted. Why? Because the last place is filled with 0. Getting my point? So your k cannot take the value 5, 10, 15, 20. Is it clear? Because otherwise the last digit will become 0, and which is not accepted. Therefore, we have to reject the value. Out of this from 1 to 24, we have to reject the values of k, like we have to reject 5, we have to reject 10, 15 also, 15 and then 20. Because in all these cases, the last digit will be filled with 0, which is not accepted. So you have to reject these 4 numbers from this total count. So there will be how many such numbers? There will be, here there are 24, but you subtract this 4, so there will be 20 such ways. 20 such ways by which these 2 places can be filled with the numbers which eventually the 5-digit number will be divisible by 4 in that case. Is it clear? So the last 2 places will be filled in 20 different ways. If these 2 places are filled in 20 different ways, naturally these 2 places will be filled by the same number, so it will be in one way. But in this position, I don't have any restriction. So any digit can come. Any digit of these 10 digits can come in the middle place. Therefore, total number of such palindrome numbers that are formed, 5-digit palindrome numbers that are formed, which are all divisible by 4, will be 20 into 10. That gives us 200. So 200 such numbers are there. Palindromic number are there. 5-digit palindromic number are there, such that they are all divisible by 4. Have you got the thing? There's a little twist. In this problem and the previous problem was a direct problem. In this problem, there's a little twist that all the palindromic numbers formed will be divisible by 4. So there is not a rocket science involved here. No. It's simply we have to find out that by the last 2 digits, if it is divided by 4, we know that that number is divisible by 4. So now we found how many such numbers are there which can be filled. I mean, the last 2 digits can be filled such that it is divisible by 24. And eventually the whole number will be divisible by 4. Getting my point? So that's the thing what we have done in this problem. Okay, let us take another sum. Find all the palindrome numbers of 6-digit. 6-digit palindrome numbers, which when divided by 4 leaves the remainder 1. Now there is another trick here. What they are saying? Nothing. In the previous sum I told you that all palindrome numbers, 5-digit palindrome numbers will be divided by 4. In this case I am not saying that. I am saying if you divide it by 4, it will give remainder 1. That is, the last 2 places when divided by 4, you must get remainder 1. Tell me yes or no. Then only the 6-digit number so formed will be, when divided by 4, leaves the remainder 1. So now the last 2 places can be filled in how many different ways? The words, I mean the numbers which will come here, which will eventually will be the form of 4k plus 1. Tell me yes or no. It will be of the form 4k plus 1. 4k plus 1 means if you divide this last 2 digit by 4, it will leave the remainder 1. And that's exactly what I want. Okay. So now, again, your k will start from what? Your k will start from 0 and it will go till 24. Because 2-digit numbers which when divided by 4 leaves the remainder 1, your k can take the value, maximum value it can take will be 24. Because if k becomes 25, it will become a 3-digit number. So that I don't want. Is it clear to everyone? Okay. So now, so how many such digits are there here? 25 such digits are there. Tell me yes or no. 25 such digits are there. Now, by any chance, think about it, by any chance, will the last digit become 0? By any chance, will the last digit become 0 of the form 4k plus 1? No. No. So I don't have to consider any other cases which has to be subtracted from this number 25. Okay, so these two places can be filled in how many different ways? In 25 different ways. Therefore, these two places will be filled in how many different ways? Only one way, because whatever number is coming here, you have to put the same number in these two places. Now, in this place, I don't have any objection, so 10 digits can come. In this place also, I don't have any objection, so 10 digits will come. Wrong. Whatever digit is coming here, the same digit will be repeated here. So this place will be filled in only one way. Is it clear to everyone? Have you understood? Now, what will be the total number of such 6 digits formed? Which when divided by 4 leaves the remainder 1? We can easily see that it will be 25 such numbers into 10. That is 250 such numbers are there. Am I correct or not? So 250 is the correct answer. Okay. So have you understood? Even if they twist the problem, there is no problem to us. Because if they say that it is find out the palindromic number, straight away, straightforward question. But if they ask you that it will be divisible by 4, or it will be divisible by 5, or it will be divisible by 11, whatever. Now we will use the, the theorem that we have learned in very childhood class for the divisibility one. That I will use here, and I will check that the number is divisible by the number which they have said in how many different ways. In that way we will do. Is it clear to all? And in this question, I have given a little twist, is that when it is divided by 4, the remainder will be 1. No problem. No problem. I will find out the last 2 digits of the form 4k plus 1. If I say that if it is divided by 4, the remainder is 3. So the last 2 digits will be in the form of 4k plus 3. That's it. Is it clear? Okay, let us take a problem which came in our JEE Main 2021. It is saying that first the definition is given. A number is called a palindrome if it reads the same backward as well as forward. For example, this is given 6-digit palindrome. Now the number of 6-digit palindromes which are divisible, which are divisible by 55. 6-digit. 6-digit number which are divisible by 55. What do you mean by divisible by 55? It means that it has to be divisible by 5. It has to be divisible by 11. That's it. It has to be divisible by 5 as well as it has to be divisible by 11, which gives us that the number will be divisible by 55. Is it clear to everyone? Absolutely. Okay. So now, what is the condition that the 6-digit number will be divisible by 5? When the last digit is either 0 or 5. But unfortunately, your last digit cannot be 0. In any palindrome number, your last digit cannot be 0. Otherwise, that 0 has to be placed in the first place and it will no more remain a 6-digit number in our case. Therefore, the last digit cannot be 0. So, the last digit will be only 5. Tell me yes or no. If it is divisible by 5, the last digit has to be 5. So, this 5 is fixed here. If 5 comes here, naturally 5 will come here. Now we have to find out. Now, in this place or in this place, whatever number comes, it doesn't matter to me. It is always divisible by 5. So this place can be filled in 10 different ways. This place can be filled in 10 different ways. And similarly, this place can be filled in 1 different way. And this place will be filled in 1 different way. So total number of 6-digit numbers, palindrome 6-digit numbers formed, which are divisible by 5, is 10 into 10, that is 100. So 100 such 6-digit palindrome numbers are there which are divisible by 5. Yet our game is not over. Why? Because now we have to check that how many of these numbers are divisible by 11. Because ultimately the number has to be divisible by 55. So it has to be divided by 5 as well as it has to be divided by 11. So we got how many numbers are there which are divisible by 5? Fine. Out of this number, you have to find out. Out of this number, you have to find out how many such numbers are there which are divisible by 11. And what is the rule for finding out the divisibility by 11? when the sum of the odd places minus the sum of the even places, it becomes a multiple of 11. That's a divisibility rule for 11. When the sum of the odd places of the number minus the sum of the even places of the number, if this difference is divisible by 11, then the whole number is divisible by 11. Is it clear? Okay. Now, in that 6-digit number, this place is 5, this place is 5. These two places are fixed. Now, let us say this place be x. I don't know which digit will come here. And let us say this place be y. So, obviously, whatever value you are putting here, you have to put the same value here. And whatever value you are putting here, you have to put the same value here. Therefore, sum of the odd places are these places. So, sum of the odd places is this. And what is the sum of the even places? The sum of the even places is this. Now, if you subtract these two, you have to get a number which is multiple of 11, and in this case, we are getting 0. We are getting 0. It means what? It means that in place of x, you can put any digit you want. From 0 to 10, any digit you can put here. 0 to 9, any digit you can put here. Is it clear? So this place can be filled in 10 different ways. This place can be filled in 10 different ways. It can be either 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Whatever digit you put here, you have to put the same digit over here. And this place also can be filled in 10 different ways. Whichever digit you put here, the same digit will come here. Is it clear? And in all these cases, the sum of these two digits will be same as the sum of these two digits. Is it clear? Therefore, what we will say that the sum of these two digits is equal to sum of these two digits. So if we take the sum of the odd terms and sum of the even terms, they are always going to come equal. Therefore, such numbers which can be formed is 10 into 10, that is 100. Tell me yes or no. Tell me yes or no. Whatever digit you are putting in place of x, you are putting the same thing there. I mean the second place from the beginning. And whatever digit you are putting in the third place from the last is the same digit you are putting in the third place from the beginning. Clear? So now if you take the sum of the odd terms minus the sum of the even terms, you are always going to get 0. Therefore, what will be the total numbers so formed which are all divisible by 11? It is 100. And see the interesting thing. We have fixed that two 5s at the last point and the first point. These two extreme points, there are 5. And since the last digit is 5, it is divisible by 5. As well as it is divisible by 11. Eventually, it is divisible by 55. Therefore, how many such numbers are there? There are 100 such numbers which are divisible by 5 and divisible by 11, and all are 6-digit palindrome numbers, which eventually says that all those palindrome numbers will be divisible by 55. Hence, our answer will be 100. Is it clear to all? Absolutely. Okay, so now I hope the palindrome number problems we can handle with. Is it clear? Conception is clear, theory portion is clear, and we have done whatever, tricks they can apply in the problem. We have done most of them. And we have also done a problem which came in 2021. So we are now comfortable with. So now let's move for the next conception. So now we will start with circular permutation. What do you mean by circular permutation? So far, whatever we have learned is what called linear permutation. So what is the difference between linear permutation and circular permutation? Whenever the question is to to arrange some objects around a round table, then it's a question of circular permutation. Whenever it's any round object, you have to arrange objects around a round object. It can be a table, it can be a garland, whatever. So if it is around a round object, and if we have to arrange objects around it, it's always a question of circular permutation. Now a big question comes. What is the difference between linear permutation and circular permutation? The only difference between linear permutation and circular permutation is that in circular permutation, there is no starting point. In case of linear permutation, you are always going to start from a particular, say, if I say I have to arrange 4 people in 4 chairs. So chairs are numbered like 1, 2, 3, 4. So your starting chair is number 1. Is it clear? But in circular permutation, there is no such starting point. And that actually creates all the problem. Is it clear? So now let us try to crack this problem in an intelligent way on the computer screen. Suppose I have given you that arrange 4 people A, B, C, D around a circular table. So this is the first case where A, B, C, D has seated on the chairs in this pattern. Okay. Now A, B, C, D, they have simply shifted their place and they are they are sitting on the circular table now in this way. What has happened? Simply, A has left this chair and came to this chair. See? B has shifted his place from this one to this one. Similarly C, similarly D. Now, I have a big question here. If I ask you, let us say in this way, a person enters a room and he observes that A, B, C, D are sitting in this way. He observes that in the right side of A, D is sitting. In the left side of A, B is sitting. And the arrangement is A, B, C, D. Now when the boy comes out of the room, what he will inform me? He will say, sir, the arrangement is A, B, C, D. Tell me yes or no. And he will say, sir, in the right side of A, D is sitting. In left side of A, B is sitting. And accordingly the other people arrangement, he will explain. Now, once they have, A, B, C, D has shifted their place. And now if a second person enters the room, what he will see? He will see that A is sitting and in the right side of A, D is sitting and in the left side of A, B is sitting. And accordingly, the other person also. Now, when he comes out, what he will report? He will say, sir, A, B, C, D, they are sitting in this manner. I will say, okay. Now, you tell me, to me, are these two things different? Answer is no. They are the same arrangement to me because I have not entered the room yet. I am sitting outside the room and people are going, they are observing their pattern and they are informing me coming out of that room. So the first person says that 4 people are sitting in the way A, B, C, D. And the second person also, he also gives the same report, said they are sitting in the manner A, B, C, D. But actually, all those people have already arranged among themselves. Isn't it so? They have already shifted one place and they have taken the new arrangement. But since there is no starting point, to me, both these arrangements are same. Now, again, let us say A, B, C, D again has shifted one place. So now they are taking this place. Now, if the third person enters the room, what he will observe? He will simply report me that, sir, the sitting arrangement is again A, B, C, D. And if I ask you, tell me who is in the right of A, he will say, sir, A, D is sitting. And who is in the left of A, he will say, sir, B is sitting. So what I will understand? I will understand that they are of same arrangement. They have not moved. To me, they have not arranged. But actually they have arranged. They have already shifted one place. Okay, next the fourth case. Again they have shifted one place. Now again the fourth person enters the room and what he will report? Exactly the same thing what previous three people have said to me. So what we have learned? We have learned though these four people, they are actually shifting their place by one seat every time. But to me, when the report is coming to me, it's all same. Because there is no starting point from where a person will say, if there is a starting point, you will say, sir, in seat A, in seat 1, A is sitting, in seat 2, B is sitting, in seat 3, C is sitting, and so on. But there is no starting point. So every time what they are saying, sir, A, B, C, D is sitting. Now maximum thing that you can ask, who is sitting in the right of A and left of A. If these two things remain same, then to you and to me, all these arrangements are same. But think about it. If this would have been a linear permutation, what will happen? See this one? These four permutations, they are different when linear permutation is concerned. ABCD, DABC, CDAB, BCDA, they are all different arrangements. In case of linear permutation, but in case of circular permutation, they are all same. So what we have learned? We have learned that when four persons were there and they are arranging in a circular table, then for one circular arrangement, only for one circular arrangement, there are four linear arrangements. Yes or no? One circular arrangement is equivalent to four linear permutations or arrangement, whatever you say. Is it clear to you? So for one circular permutation, we are having four linear permutation. Let us say, total number of circular permutation for these four people be X. So what I will write? For one circular permutation, there are four linear permutation of these four people. So I have said that, let us say, the total number of circular permutation for these four people A, B, C, D be X. So for X circular permutation, total linear permutation will be what? 4 times X. This is the total linear permutation. Tell me yes or no. So there will be 4 linear permutation for one circular permutation. This we have understood. Now for X circular permutation, there will be 4X linear permutation. Now if I give you 4 people, what is the total linear permutation among these 4 people? It is nothing but factorial 4. It is nothing but factorial 4. So can we say that 4x is the total linear permutation of these 4 people, which is equals to nothing but factorial 4. Because factorial 4 is the total linear permutation between, among the 4 people. Therefore, you can write in this way also. It can be written as 4p4 also. So x will be what? Your x will be factorial 4 divided by 4. So that gives us 4 into factorial 3 divided by 4. That gives us factorial 3 only. So what we have learned? We have learned when 4 people are sitting in a circular table, they can be permuted, not in factorial 4 ways. Factorial 4 ways is for the linear permutation. But we have seen right now that for circular permutation, the number will be factorial 3. Is it clear? So we can generalize this. We can say if there are n people sitting around, a round table, then total number of circular permutation will be n minus 1 factorial. Is it clear or not? This can also be written in this way. It can be written as circular permutation can also be written as npn divided by n, which actually gives us n minus 1 factorial. Tell me yes or no. Have you understood the logic? Is this logic clear to you? So whenever I say that n person are sitting around a circular table, the total number of circular permutation will be n minus 1 factorial, which can also be written as npn divided by n. Now, why I am writing in this form? Why I am insisting you to remember in this form? Because suppose if I say that there are n people, out of which you are taking r people out of that, and you are then arranging around a round table. So in that case, the total number of circular permutation will be, there are n people and you have taken r people out of that and you have arranged them in a circular table. That will be npr divided by factorial, divided by r. Is it clear? Have you understood it? Because it is same thing. You see, if there are r people, out of n people you have chosen r people. So actually you are arranging r people around the circular table. So for one circular permutation, there will be r linear permutation. So if I say that there will be x such circular permutation, then the total linear permutation will be xr. Now out of n, if you choose r and if you permute, what is the total number of permutation? What is the total number of permutation taking r from n distinct objects? It's nothing but npr. So this is nothing but your npr. So that gives us x is nothing but npr divided by r. That is why I told you to remember in this way. In this case, what happened? There are n people and we have already taken n and we have permuted around the round table. That is why it is npn divided by n. Is it clear to all of you? Which is same as your n minus 1 factorial. There is no problem. But have you understood this logic? Absolutely. So what is the major difference of circular permutation and linear permutation? The circular permutation doesn't have any starting point. And that actually creates all the problem. But linear permutation, they always have a starting point. Is it clear? And for n people to arranged in a linear way, the total number of permutation will be factorial n. But if this n people are seated around a round table, then the total number of circular permutation will be n minus 1 factorial. Is it clear to all? Okay. Now let us consider a more interesting thing. Suppose I have said that A, B, C, D, these 4 people are arranged in a circular table. Now, this is one arrangement. Okay, A, B, C, D are sitting in this arrangement. Now, can you please tell me what will be the total number of arrangements in which these 4 people can sit in the circular table? It will be nothing but factorial 4 minus 1, that is factorial 3. Am I correct? Now, in this number of ways, there is one way where these 4 people on this circular table has seated in this fashion. What they have done? They have simply, B has changed its place to D and D has changed his place to B. Okay? In this case, observe this thing. This is one arrangement. This is another arrangement. And all those arrangements are very much involved in this factorial 3. Am I correct or not? Because the 4 people are arranged in this circular table in factorial 4 minus 1 ways. So that is factorial 3 different ways. So out of that ways, this is one way. I mean the first way and the second way, these are the 2 different options which are very much involved in factorial 3. But now, if I say that these 2 arrangements, that is the clockwise and the anti-clockwise arrangement, they are same. What I have said? Clockwise and anti-clockwise arrangement are same. Then what will happen? If these 2 arrangements, to me, they are same. Think about it. What we have done, actually if you see the figure, you will find that I have simply flipped this figure. I have simply flipped this figure to get this one. And both these arrangements, they are same. That is, clockwise and anti-clockwise arrangements are same. If it is so, then is it not, if I ask you, now you tell me how many number of different arrangements they can do. So what will be your answer? Your answer will be, sir, it will be factorial 3 divided by 2. Why it is so? Because for every clockwise arrangement, there is always an anti-clockwise arrangement, which are, in this case, which are same. Which are same. Therefore, total number of distinct arrangements that can happen is factorial 3 divided by 2. That's it. Is it clear to all? So when the clockwise and anti-clockwise arrangements are same, then what is the total circular permutation? It's the normal formula, that is n minus 1 factorial divided by 2. That's it. So if I say that there are n people sitting around a table, the total number of circular permutation will be n minus 1 factorial, in which your clockwise and anti-clockwise arrangements are different. Then the total number of circular permutation will be n minus 1 factorial. But if the clockwise and anti-clockwise arrangement are same, then the total number of circular permutation will be half into n minus 1 factorial. Is it clear to all of you? Have you understood? You see, how you will understand this clockwise and anti-clockwise arrangements are same? If they say you in the question, then it's okay, then it's fine. But if they don't say, then always think in this way, that if you can take the whole object in your hand, you see, 4 people are sitting on a table. You cannot take that table in your hand. That you cannot do. But anything, any circular object, which you can take in your hand, can be flipped. Can be flipped. So in that case, we will assume that clockwise and anti-clockwise arrangements are same. Like I can say, let us take a necklace. A necklace, all the pearls are there on a necklace, right? All the pearls, they are arranged in that circular fashion on the necklace. Now you can take that necklace in your hand. So easily you can flip it. So if you can flip it, what will happen? the total number of distinct circular permutation will be half times n minus 1 factorial. Have you understood this? You can take the example of a garland also. Garland, you can take it in your hand, but you cannot take a table in your hand. So in the table, when the people are sitting on the table, in a circular table, so in that case, your clockwise and anti-clockwise arrangements, they are different. Otherwise, any object which you can take in your hand, in that case, your clockwise and anti-clockwise arrangements, they are same. Is it clear to all? So we can generalize this formula in this way also. If there are n objects, n distinct objects, out of which you are taking r at a time and you are permuting it on a circular arrangement, and clockwise and anti-clockwise arrangements, they are same. So in that case, the total number of circular permutation will be, we have already learned this. In this case, it will be divided by 2r. Is it clear? So what is NPR by 2r? It is the total number of circular arrangement of r objects taken from n distinct objects and permuting it in a circular fashion, where the clockwise and anti-clockwise arrangements, they are same. Is it clear to everyone? So let's take a problem and let us understand the fact more clearly. In this question, they have said in how many different ways 5 boys and 5 girls form a circle such that the boys and girls are alternate. Now my first question is that here clockwise and anti-clockwise arrangement are same or different? Obviously different, because they are sitting on a circular, around the circular table, or they are forming the circle, whichever. It actually carries the same meaning. So in this case, your clockwise and anti-clockwise arrangement, they are different. Okay? Now, let us see. Let me just draw a circle first. And let us do one thing. Since the boys and girls are sitting alternately, so we are first placing the 5 boys at 5 places. Let us say this is B1, this is B2, this is B3, this is B4, and this is B5. Is it clear? So 5 boys already seated on that circular table, leaving 1 seat in between. Now tell me, how many different ways these 5 boys can be seated in this circular table? They can be seated in 5 minus 1, that is factorial 4 different ways. Tell me yes or no. Now, the moment boys are placed on the table, now the seats in between, this will form the linear permutation. Why? Because the moment the boys take their place, so in between whatever seats is vacant, that seat is now defined. Why that is defined? Because let us say these are the 5 seats in between, right? Now this seat is different from this seat. Why? Because in this seat, if one girl comes, let us say G1 comes, and if G2 comes here, now in G1, the right hand side of G1 we are having B1, and in the left hand side we are having B2. So this seat is defined. If we consider this seat, and G2 has take her place on that seat, so in the right side of G2 it is B2, and in the left side we are having B3. So these 2 seats, they are different, they are not same. Are you getting my point? Suppose if we, let us say, here is G1, here is G2, here is G3, here is G4, and here is G5. Now you tell me one thing. This one is G1, this is G2, and G3 here, G4 here, G5 here. Now let them move one set. Let G1 comes here, G2 comes here, G3 comes here, G4 comes here, and G5 comes here. Now you tell me, is this arrangement and the previous arrangement the same? No. Why? Because in the previous arrangement, in the right side of G1 was B1 and in the left side was B2. But in the second case, in the right side of G1, we are having B2 and in the left side, we are having B3. So these two are different arrangements. It means we are taking, whenever these girls are taking their place, it will be no more remains a circular permutation because the place has already been defined. In linear permutation, the place is defined. In circular permutation, place is not defined. Are you getting my point? When we are putting that B1, B2, B3, B4, B5, in that case, we don't have any marking. We don't have any starting point. So that arrangement of boys was a circular permutation. But arrangement of girls, the moment boys took their place, now the place in between, they are now identified. One place is between B1, B2, another place is between B2 and B3, so these two places are different. So it has a starting point, it has an end point. So in this case, when the girls are sitting in this 5 vacant seats in between the boys, these 5 places and these 5 girls will be arranged in linear permutation way. Is it clear? So the arrangement of the girls will be linear permutation. So they can arrange among themselves, the 5 girls can arrange among themselves in 5 places in factorial 5 different ways. Therefore, the total number of ways when boys and girls are alternate is 24 into 120. That gives us 2880. Is it clear? So that's our answer. Have you understood? Because this question is pretty simple question, but very good question to understand. When the boys, first when we are putting the boys, then we don't have any starting point. No seats are identified by a specific number or whatever position. We don't have any particular specific thing such that you can define that set. That is, there is no starting point. So when boys are placed in the 5 places, they will be placed in circularly. The circular permutation will take place. But when the girls, after the boys take their place, so in between places, now these places are identified. Though it has not been numbered, but you can say that one place is between B1, B2. Another place is between B2 and BC. You see, you can identify the place. So these places are different. So when the girls, you are putting it in between that, between the boys in the vacant place, the vacant set, they will be permuted linearly. Have you understood? Is this conception clear? Okay, let's move for the next problem. See this question. 20 persons are invited to a party. In how many ways can they and the host? So total there are 20 persons and 1 host. So there are actually 21 people. Right? Now the question is, in how many different ways they can be seated at a circular table? So naturally, the total number of ways they can arrange among the, on the circular table in 21 minus 1 factorial different ways. That is, factorial 20 different ways. Is it clear? 21 people are there. You are arranging them on a circular table. So they can be arranged in 21 minus 1 factorial. That gives us 20 factorial different ways. The second question says, in how many of these ways will 2 particular persons be seated on either side of the host? That is, your host is here and two particular person are there, let us say P1 and P2. These two people will always sit on either side of the host. So in how many different ways we can arrange those people on the circular table? How to do this? Simple. Let us make P1, H and P2 as my one unit. Because wherever they will move with that complete set. Okay? So eventually your two particular person P1 and P2 will be always on the either side of the host H. Clear? Okay. So if we combine this, so now how many people are left? We are left with 18 people. So total in our case, in this case, total there are 19 people. Why 19 people? Because this whole thing I have taken as one people, as one person, right? P1, H, P2 as my one person. So total there are 16 people. 19 people. So these 19 people can arrange among themselves on the circular table in 19 minus 1 factorial. That is factorial 18 ways. Am I correct or not? But in every arrangement, this P1 and P2 can interchange their place. The question is, the two particular person P1 and P2, they will be on the either side of H. Whether P1 is in the left side of H or right side of H, it doesn't matter. But P1 and P2 will be always on the either side of host H. So P1 and P2, they can arrange among themselves in factorial 2 different ways. So total number of ways will be factorial 18 into factorial 2. Is it clear or not? Is it clear or not? The two particular person will be always on either side of the host. So I have taken those two particular person and host as my one unit. So we are left with 18 people and this one particular, set. So total there are 19 objects to us or people to us. So they can arrange in the circular table in 19 minus 1, that is factorial 18 different ways. But P1 and P2, they can interchange their place. And that can be done in factorial 2 different ways. Is it clear? Therefore, the total number of ways will be factorial 18 into factorial 2. That's your answer. Is it clear? Okay, let's take another problem. How many garlands can be made using all of the 8 different flowers? Now, it's a question of garland. Whenever it's a question of garland or it's a question of necklace, means these are the circular arrangement which you can pick up in your hand. So total number of circular arrangement will be, as usual, n minus 1 factorial, no problem, but it will be divided by 2. Because in this case, clockwise and anti-clockwise arrangement, they are same. Is it clear to all? So in this case, what we will do, since there are 8 different flowers, so they can be arranged in the garland in 8 minus 1 factorial different ways, but it will be divided by 2 as just now I have explained. Anti-clockwise and clockwise arrangements are same in case of garland or necklace. Therefore, total number of ways will be half times factorial 7. Is it clear? Let us take the next problem. How many necklaces of 6 beads each can be made from 10 beads of different colors? Now, you have to make a necklace with 6 beads, and the 6 beads will come from 10 different beads which are given to us. Clear? So what will be the total number of arrangement? It will be 10p6. It will be 10p6. This is the linear arrangement. I have taken 6 beads out of the 10 beads. But since you are arranging them in the necklace, means your clockwise and anti-clockwise arrangements, they are same. So it will be divided by 2r. 2r means here r is 6. So your answer will be 1 over 12, 10p6. Is it clear to all of you or not? Have you understood this? What I taught you, that is the reason why I taught you. Okay, remember in that way, npn divided by n. Okay, so same thing here, npr divided by r, but since it is arranging on a necklace, it will be divided by 2. So it will be divided by 2r. So that's exactly what we will get, and the answer is coming to 12,600. So let me just open this one. It is factorial 10 divided by 10 minus 6 factorial, which gives us actually 1 over 12 into 10, 9, 8, 7, 6, 5 divided by factorial 4 into factorial 4. So this goes off. 12 goes off, 6, 2, and then it is 5. So we are having basically 9 5s are 45, 7 8s are 56 into 5. So 45 into 5 gives us 225 into 56, which is 12,600. That's your answer. Calculation part, leave it. But understand the logic. Have you understood it clearly? Whenever it's a question of necklace or garland, without thinking anything else, you always remember clockwise and anti-clockwise arrangements, they are same. So what we will do? We will do it normally, but it will be divided by 2. Normal circular arrangement we will do, but it will be divided by 2. That's it. Clear? Let's move for the next problem. See this question. In how many ways 6 men be seated around a circular table such that they don't have same neighbors? Very, very important question. They don't have same neighbors. You see, here you have to identify, mainly you have to identify whether these are two things you have to identify. One is whether it's a circular arrangement or linear arrangement. And number 2, whether the clockwise arrangement and anti-clockwise arrangement are same or distinct in case of circular arrangement. In case of circular permutation, whether these two things are different or same, that only you have to understand. That's it. Now they have said in this question that there are 6 men seated around a circular table such that they don't have the same neighbor. Let me just draw those 6 men. Let us say these are the 6 men. Let me give a name. A, B, C, D, E, F. Okay. Now, can you please tell me who are the neighbors of A? Who are the neighbors of A? They are F and B. Is it clear? Now what I'm doing, I'm simply flipping their sets. Here is A. Now B is sitting here, C is sitting here, D, E, and F. Now you tell me, is this arrangement and this arrangement are the same or different? Are the same or different? That is, the clockwise arrangement and the anti-clockwise arrangement are the same or different? They are absolutely same. Question comes why? Because what they have said, they don't have same neighbors. In the first case, the neighbor of A is F and B. In the second case, the neighbor of A are B and F. Same thing. So even if we flip their seats, we are having the same neighbors of every person. I have only considered A. You consider each and every person, you are going to have the same neighbors. It means your clockwise and anti-clockwise arrangements are same. Have you understood it? Have you understood it clearly? So whenever it's a question of garland, or it's a question of necklace, or in the question if they tell you that they will not have the same neighbor, in all those cases, your clockwise and anti-clockwise arrangements, they will be same. Remember that. So the 6 men can sit around this table in how many different ways? It will be 6 minus 1 factorial, which gives us factorial 5, which is nothing but 120. Is it clear? Now, as the clockwise and anti-clockwise arrangements are same, therefore, total number of ways, total number of distinct ways will be 120 divided by 2, that gives us 60. Is it clear or not? That means for one arrangement, whatever arrangement you have chosen, if you flip it, you are going to have the same arrangement. So I will not take that arrangement. I will not take that arrangement into our consideration. And that is why I have divided by 2. Why? Because for every arrangement, every regular arrangement, you are always going to get a flipped arrangement of that. And I don't want that flipped arrangement. That is, I don't want that any neighbors should be same. Is it clear to all of you? Absolutely? Okay, so let's move for the next problem. Question says, in how many ways 5 cricketers and 5 footballers can be seated around a circular table such that all cricketers are together? So here what we will do, I will take all those 5 cricketers in one box. All the 5 cricketers, let us say C1, C2, C3, C4 and C5, they're in one box. And I will treat this thing as my one object. And there are 5 footballers also. Now there will be total 6 objects. I am treating those cricketers and footballers, individual cricketers and footballers as one object. So now we are having 5 plus 1, that is 6 different objects which will be arranged around a circular table. Therefore, the total number of ways in which these 6 objects can be arranged in a circular table will be 6 minus 1 factorial. That gives us factorial 5. Now, as these 5 cricketers are sitting together, so they can arrange among themselves in factorial 5 different ways. So, total number of ways in which all cricketers will be together is factorial 5 into factorial 5, which gives us factorial 5 whole square. Right? Now, let us see the second question. It states, all cricketers and all footballers are together. So cricketers, all cricketers I made in one box, and let us now put all those footballers, all those 5 footballers in one box. Okay, so now we are actually having 2 objects to be arranged around the circular table. Is it clear? Because this is my one object, all the cricketers, and all the footballers as my other object. So we are actually having 2 objects which can be arranged around a circular table in 2 minus 1 factorial, which gives us 1 factorial, that is 1 only, right? Now, in every arrangement, these 5 cricketers can arrange among themselves in factorial 5 different ways. And 5 footballers can arrange among themselves in factorial 5 different ways, which gives us factorial 5 whole square. So all cricketers and all footballers will be together. The total number of ways will be factorial 5 whole square. Now, see the third question. They are saying not all footballers are together. Not all footballers are together. What do you mean by that? It means that if 2 footballers are together or 3 footballers are together, that is accepted. But not all the footballers will be together. You have to find out that number of arrangements. Not all footballers will be together. Getting my point? Okay. Let us just assume that these 5 cricketers and 5 footballers, without any restriction, they can arrange among themselves around the circular table in 10 minus 1 factorial, which is 9 factorial. Because there are 5 cricketers and 5 footballers, so there are 10 objects. So these 10 objects can placed around the circular table in 10 minus 1, that is 9 factorial. Clear? Now, all the footballers are together. All the footballers are together. So what will be the total number of ways? Let us just consider all the footballers in one box. So we are now having 6 objects. What are those? This one box, all the footballers are together. This is my one object, and there are 5 cricketers. So there are 6 objects to me. Is it clear? Now these 6 objects can arrange among themselves around the circular table in 6 minus 1 factorial, that is 5 factorial. And in every arrangement, these 5 footballers can arrange among themselves in factorial 5 different ways. Therefore, the total number of ways in which these 5 footballers will be together is factorial 5 into factorial 5 whole square, right? So now, what are the total number of ways where not all footballers are together? Which is nothing but total number of arrangements minus when all the 5 footballers are together. I'm not going for the calculation. I'm simply leaving it like this. So total number of ways where not all footballers are together is this. Is it clear? Not all footballers together means 2 footballers, 3 footballers, 4 footballers, they can be together. I don't mind. Even if they are separated, then there is no problem. But not all footballers should be together. Clear? The next question is, no 2 cricketers are together. Very important point. No 2 cricketers are together. It means what? No 2 cricketers will be together. Means they are asking for the gap method. Can you understand this? So let me do one thing. Around the circular table, let me first place all the 5 footballers, keeping 1 seat vacant between each of these places. So these 5 footballers, they can arrange among themselves in 5 minus 1 factorial, that is factorial 4 ways. Because when you are putting those footballers, there is no starting point. So it's a circular permutation. And in circular permutation, total 5 objects can be arranged around a circular table in 5 minus 1, that is factorial 4. Getting my point? So total number of ways these 5 footballers can be arranged are factorial 4 different ways. Now, there are 5 sits in between those 5 footballers. So in this place, the number of ways in which 5 cricketers can be placed will be factorial 5 different ways. Same logic. The moment the footballers take their place, now the in-between places are identified. They are marked. Some place is between B1, B2, which is different from some place which is between B2 and B3, which is different from some place between B3 and B4. Getting my point? So the moment the footballers take their place, all the places in between, they become identified. They become a particular place. That means, in other words, you can say these places are now indirectly being numbered. So when these 5 places are filled by the 5 cricketers, then it will be simply a linear arrangement, not the circular arrangement. Be careful about it. So 5 cricketers can sit in this 5 vacant places in between in factorial 5 different ways. Tell me yes or no. Yes or no, because this will be your linear permutation. Therefore, no cricketers will be together. Will be why I have written 2 times factorial 5. This is actually factorial 4, right? Factorial 4 is the number of ways in which 5 footballers are placed on the circular table. And factorial 5 is the total number of ways when the cricketers are placed in between the vacant set. Therefore, no 2 cricketers will be together. The total number of ways is factorial 4 into factorial 5. Is it clear to all of you? Is this clear? So the first place, these are the answers. You can check it. This is the first one. This is the second one. This is the third one. And this is the fourth one. Yes. Is it clear to everyone? Absolutely. No doubt about it. Now I hope you have understood the difference between the circular permutation and linear permutation. Though they are arranging around the circular table, the moment the places are identified, they become linear permutation. And when the places are not being identified, I mean, there is no starting point, always consider that as a circular permutation. Clear? Let me take another problem. See this question. In how many different ways 5 boys and 5 girls be seated around the round table such that boys and girls are alternate and B1, G1 are never together? Can you remember we have done same kind of problem in my previous class where 2 particular persons were never together? Can you remember? But still they are sitting in the alternate way. This sum we have done already in my previous class, but that was linear permutation. They were arranged in a row. Now in this problem, the 5 boys and 5 girls are seated around the round table. So let me do one thing. Let us just close this B1 and G1 in one box. So we are left with actually B2, B3, B4 and B5. These are the 4 boys. And we are left with G2, G3, G4 and G5, right? Now let me do one thing first. Let me place those 4 boys and these 4 girls around the round table in alternate way. Clear? What I'm saying is, let me just place these boys first. So I have placed these 4 boys in these 4 places, which can be done in 4 minus 1, that is factorial 3 different ways. Is it clear? Because now this is a circular permutation. But when these 4 girls are placed in between, they will be not circular. They will be not the circular arrangement. Why? Because now the seats are identified. So therefore, there are 4 seats in between. There are 4 seats in between, and the 4 girls can be placed in these 4 seats in how many different ways? In factorial 4 different ways. Therefore, the total number of ways in which B2, B3, B4, B5 and G2, G3, G4, G5, these 4 boys and these 4 girls can sit alternately around the round table is factorial 4 into factorial 3. Am I correct? Now the big question. I have to place this B1 and G1 in such a way. What I'm actually trying to do, I'm trying to find out the number of ways in B1, G1 will be together. And then what I will do, I will simply subtract those numbers from the total number of ways when there is no restriction on B1 and G1. Though they are sitting alternately, but there is no restriction. for B1 and G1. Okay, they can come together, they can be separated, doesn't matter. So what I will do, I will simply subtract the first number from the second one. That is, I will subtract the total number of ways where B1 and G1 are together from the total number of ways when boys and girls, they are alternate. But B1 and G1, there is no restriction on them. So naturally what we are going to have? We are going to have the total number of ways when the boys and girls will be alternate, but B1 and G1 will never be together. Are you getting my game plan? How I'm entering into the problem? Okay, so this is the total number of ways in which B2, B3, B4, B5 and G2, G3, G4, G5 are sitting alternately. Now, let us think about it. Let me just take one case here. Let it be G2, G3. This is one of the arrangement when the girls are seated in these vacant seats. Now, suppose B1 and G1 are sitting in this manner. So they can be placed between these boys and girls in such a way that the alternate thing is maintained. The alternate thing is maintained. That is boy, then girl, then boy, then girl, and this thing goes on. And at the same time, B1 and G1 are together. So I can place this if B1 and G1 are sitting in this way. So they can be placed either here, or can be placed here, or can be placed here, or can be placed here. Check it out. There are 4 such places where B1 and G1 can be placed when B1 and G1 are sitting in this manner. Because if you place those B1 and G1 box in this crossed places, then your boy, girl, this rule will still valid in our problem. Okay? So there are 4 such ways in which they can be placed if B1 first and G1 second, they take the place in this way. Now, if the place is something like this, if they interchange their place and girl 1 comes first, boy 1 goes second. Now, if the arrangement is this, then they can be placed, look it very carefully, they can be placed to maintain the boy-girl alternate thing. Maintaining that this box can be placed either here, or here, or here, or here. Look it carefully. Because if this box is placed here, then the boys and girls, they will be alternate in which way? See, first is B4, then will be G1, then B1, then G5. Getting my point or not? So this alternate thing is still there. So total number of ways in which this B1, G1 can be together, as well as all the boys and girls are alternate, will be this into 8. Because there are 8 places in which B1, G1 or G1, B1 can be placed accordingly. Therefore, the total number of ways will be factorial 4 into factorial 3 into 8. This gives us what? This gives the total number of ways in which boys and girls are alternate and B1, G1 are always together. Now, without any restriction, 5 girls and 5 boys can arrange among themselves alternately in how many different ways? Without any restriction. The only restriction is that boy and girl, they are alternate. So in how many different ways this place people can sit? Say this is B1, B2, B3, B4 and B5. Okay? And your girls will be placed here. So boys can be placed in the circular table in 5 minus 1, that is factorial 4 different ways, and the girls can be seated in between. In how many different ways? In factorial 5 different ways. Yes or no, tell me. Yes or no, tell me. So this is what? This is the total number of ways in which 5 boys and 5 girls are sitting alternately. But there is no restriction on B1 and G1. Clear? They can sit anywhere. Now, the total number of ways in our problem will be what? Factorial 4 into factorial 5, where there is no restriction, minus the total number of ways when B1 and G1 are together. So that gives us what? When B1, G1 are never together. Are never together. Getting my point? But they are sitting alternately. All boys and girls are sitting alternately. But B1 and G1 will never be together. Will be what? Factorial 4 into factorial 5 minus factorial 4 into factorial 3 into 8. So let me just calculate this. Let me take factorial 4 common, factorial 3 common. So we are left with 5 into 4 minus 8. So that gives us 24 into 6 into 5 4s are 20 minus 8 gives us 12. So it is 24 into 72, that gives us 1728. Is it clear to all? So total number of ways in which this 5 boys and 5 girls can sit alternately, but B1 and G1, they will be never together, is 1728 ways. Is it clear to everyone? Absolutely. So now let's move for, I hope now, the circular permutation thing is very clear to all of you, because we have taken a lot of examples here and we have discussed one by one and all the critical points that are mainly involved in circular permutation, right? So now let's move for a new conception. So now we are going to discuss about the rank of word in dictionary. What do you mean by this? What do you mean by rank of word in a dictionary? Suppose we have been given a word, and in all possible ways, if we arrange those alphabets involved in that word, we are going to get different words. And now all these words are put in a dictionary in alphabetical order. Because in dictionary, whatever words you are putting, it is always in the alphabetical order. Now, if you placed all those words, the word which is given to us is one of the words among the whole arrangement. The question is, that particular word will definitely come in the dictionary. When you are putting all those words alphabetically, that particular word will come someplace. The question is, what will be that, what is the number? If you start counting all the words arranged in the dictionary, what will be the point where the given word is placed? That is, on which number, if we count all the numbers placed in the dictionary, what will be the count of that particular word which is given to us? Now, in mathematical way, we call this thing as rank of that word. Is it clear? So any word which is given to us, the question will be in this way, that if all the words are placed after arrangement, if all the words are placed in a dictionary, what is the rank of that word? Is it clear? Now you have understood what is rank of a word in a dictionary? Okay. So now let me take one example. Before that, let me just write it. So what is rank? Whenever a word is given, any word which is given to us, you arrange all those words in all possible manner, and then you put all those words in a dictionary. We all know that in a dictionary, all the words used to come in alphabetical order. So you placed all those words in the dictionary, and the word which is given to us will come somewhere in this after placing the words. So naturally that word will also come and it will take some place. The rank means what will be the position of this word from the first one. That's what is called your rank. Is it clear? Okay, let me take one example. See this question. They have said if all the letters of the word mother, be arranged in a dictionary, then find the rank of the word mother. So what I will do, first you tell me how many number of such words by taking all the alphabets of mother, if they arranged, you will get. We are going to get factorial 6, that is 720 words. Now in this 720 words, there is one word which is mother. The question is, now you put all the the words in the dictionary, so your mother will come somewhere. What is the count of that word mother from the very first word placed on the dictionary itself? Is it clear to all? So for that, what I will do, let me first denote all the alphabets in alphabetical order. The first is E. Then it's coming like H, then M, then O, then R, then T, right? So whenever you are putting all those 720 words in the dictionary, so naturally the first words that will come will start with E. So how many such numbers are there? First let me count that. First you place E, and then all these 5 places can be arranged in factorial 5 different ways. That is 120 words. So all these 120 words are started with E. So their first place on the dictionary. After that, it will start alphabetically. So naturally H will come. And again in that case, total number of words formed is 120 again. So all those 240, till this it's 240. So all those 240 words are placed in the dictionary. Now alphabetically after H, your M will come. The moment M comes, alphabetically it has to start with E. So all the words which are started with M and E will be how many words? It will be factorial 4, which gives us 24. Is it clear? After that it will start with, after E, alphabetically H will come. And it will be again factorial 4, which gives us 24. Okay? After H, alphabetically O should come. This O should come. So now after M, O is coming. O will not be used anymore because here no alphabets can be repeated. How can you repeat an alphabet? How can you repeat M twice? We are having only one M. So we cannot repeat any alphabet at any number of times. We cannot do that. So now it is M-O. So after that, alphabetically it must start with E. After O, alphabetically it should start with E. So if it is E, then how many number of words will come? It's factorial 3, that is 6. After that, alphabetically H will come. Then again factorial 3, that is 6 words gone. After that, it will give us R. Again factorial 3, that is 6 words gone. All are placed in the dictionary, yet your mother has not come. After R, according to the alphabets given to us, it will be M, O, R is gone. So naturally now T will come. The moment it comes T, now alphabetically it should start with E. And how many such numbers will be formed? It will be factorial 2, that is 2. Are you understanding why I'm writing factorial 2? Because at these two places, two alphabets can arrange among themselves in factorial two different ways. In this case also I have written factorial 4. It means that in these four places, the four alphabets has arranged among themselves in factorial 4 different ways. Okay, so after E, alphabetically H will come. H will come. And after H, automatically, alphabetically what will come? E will come. Once E has come, you have to block it. And then alphabetically only the alphabet R is left. So that place has to be counted. So that is 1. So what will be the rank of the word mother? We will simply add all those, we have to count all those words which are placed before mother. Okay? And mother has occupied one place, so we have to calculate that also. Therefore, the rank of the word mother will be 240 from here, 24, 6, 30, that is 60. And then it is 6, 2 and 1, that is coming to 9. So it is coming to 309. And that is the rank of the word mother. Is it clear? So what is the rank of the word mother? That is when all the words are placed alphabetically in the dictionary, the word mother takes the place 309 from the first place, the first word that has been placed in the dictionary, right? Now, this is a question that we have done by analytical method. I hope it is clear to all of you. But in entrance exam, if this question comes, we cannot give so much of time solving this problem in this way. So naturally, we have to go for some shortcut trick to solve this kind of problem at ease and at very quick interval of time. So now you see the shortcut method. This is the shortcut method. Listen it very carefully. How we will do this? We are having MOTHER. The first step is you simply write down, you give a number to all the alphabets which are coming alphabetically. So first E will come, say 1. Then H will come, this is 2. Then M will come, this is 3. Then O will come, this is 4. Then R will come, this is 5. And then T will come, this is 6. So first you simply give the number of all the alphabets involved in the given word alphabetically, right? After that, what I will do, now listen it carefully. First I am considering the word, the alphabet M. You have to see what is the number you have assigned with M. It's 3. Now you see the right side. You see the right side of M and check how many numbers are there which are less than 3. In the right hand side of M, you find out how many numbers are there which are less than 3. So I can easily see that less than 3 is only 2 and 1. So there are 2 such numbers. So write down 2 over here. Then you consider the next alphabet O and check how many numbers are there which are below 4 in the right hand side. So there will be 2 and 1 again. Below 4, which are less than 4, it's only 2 and 1. So again you will write 2 over here. Then consider the third alphabet, which is your T, and the number that has been assigned with T is 6. Find out in the right hand side how many numbers are there which are less than 6. And we can easily see that there are 3 such numbers. Because 2, 1 and 5 we are having, all are less than 6. Then you consider H. And the number which is assigned with H is 2. So how many numbers are there which are less than 2 in the right hand side? Only one. And then you consider the next alphabet E, and the number which has been assigned with E is 1. So how many numbers are there in the right hand side of E which are less than 1? No number. Similarly with 5 in the right hand side for this alphabet R, the number assigned is 5, and in the right hand side we are having no alphabets. Therefore, again, how many number of alphabets are there in the right hand side? It's 0. So this much you have to do. Pretty simple. First, what we have done, simply I have assigned a number with all the alphabets involved in the given word alphabetically. And after that I have checked by taking each and every alphabet, I have checked how many numbers are there which are less than that number which has been assigned to that alphabet. So accordingly you simply write down those numbers. And then you write down every time. You start from the extreme right and write down factorial 0, factorial 1, factorial 2, factorial 3, factorial 4 and factorial 5. Every time start with factorial 0 from the right side and go in the left hand side by increasing one digit every time. And after that, you simply add those values. First, what you will do, you will multiply 2 with factorial 5. Factorial 5 is 120 multiplied by 2 gives us 240 plus factorial 4 is 24 multiplied with 2 gives us 48. Write it down. Factorial 3 is 6. Multiply with this 3, you are getting 18. Then multiply with factorial 2, which is 2. Multiply with 1, you are getting 2. And then when 0 is multiplied with factorial 1, it gives us 0. 0 is multiplied with factorial 0, again it is 0. So now look it carefully. If I add those, what you are getting? 240, that is 288 plus 20. So that gives us 308. Am I correct? So now, whatever answer you got, be very careful. You simply add 1 to that answer to get the final rank of the word mother in this case. Is this clear? Is this shortcut clear? At last, don't forget to add 1. Then only you will get the rank of mother. Otherwise, 308 is basically all the words which are above mother. Getting my point? Because alphabetically you are putting all those words in the dictionary. So 308 is before mother. And I asked you to find out the rank of mother. So mother has to be taken into consideration. So that 1 is to be added at last. Is it clear? This is the shortcut way of finding out the rank of the word mother in the dictionary. So I have taken mother. Now you can take any word and you can easily find out its rank by using the shortcut method. Okay. So now you please comment me what will be the rank of father. That is when you arrange all the alphabets of the word father and you arrange them in a dictionary. So naturally a place will come where father will come. You have to find out what is the rank of that word father. And definitely comment me. I will check it. Okay, so let's move for the next problem. 309 is the correct answer. In this question they have said that if all the letters of the word Kolkata be arranged in a dictionary, then find the rank of the word Kolkata. Now in this question, if you compare this with the previous one, you will find definitely the word is different. But apart from that, one major difference is that in the word mother, no alphabets there were repeated. Isn't it so? But in case of Kolkata, the alphabets are repeated. So in this case, how we will find out the rank of the word Kolkata? First we will do by analytical method. Then at last, definitely I will give you a shortcut method for finding out the rank of any word when repetition of alphabets are there. Okay? So let's move to the computer screen. The word Kolkata is given. So alphabetically the words will be, we are having two A's, then two K's will come, then L, then O, then T. Now, first, all the words will start with, we are having 7 alphabets, right? So all the words will start with A. Now, if the word is started with A, we are left with 6 places and we are having 6 alphabets. Now, these 6 alphabets can arrange among themselves in factorial 6 different ways, but 2 K's are identical, so it has to be divided by factorial 2. Now, one question can come, sir, why you have not divided by factorial 2 more? Because there are 2 A's. No. Try to think about it. 1 A has been fixed in the first place, so it cannot move. Therefore, these 2 A's, though there are 2 A's, actually 1 A is moving in the rest 6 places. Therefore, you should not divide it by factorial 2. Is it clear? Next word will start with, alphabetically, don't start with A again, because A has already been taken. So next word that will start is with K. The moment you get K, the next alphabetical word will come A. Now you fixed A over here, and the rest 5 places can be filled by 5 different alphabets now, because 1 K is fixed, 1 A is fixed. So we are left with 1 A, 1 K, L, O and T. So we are having 5 different alphabets. Therefore, 5 different alphabets can arrange among themselves in factorial 5 different ways. Then alphabetically, it will start with K again. Now, if K comes, then we are having 5 places, out of which you observe your 2 A's are identical. Therefore, the total number of such words can be formed is factorial 5 divided by factorial 2. After K, what will come? It will come KL. Am I correct? It will start with KL. Now, how many alphabets we are left with? Again, we are left with 5 places and 5 alphabets. So they can arrange among themselves in factorial 5 divided by factorial 2 only. Why? Because only 2 A's, identical A's are available. 1 K is fixed, so I cannot divide it by factorial 2 again. Getting my point? Because your 2 K's are not available right now when you are arranging these 5 alphabets. Only 1 K is available. Because 1 K is already fixed, so that cannot move. Is it clear? Okay. So after ending with KL, starting the words with KL, it will start with KO. So the moment you get O, again it will come, alphabetically it will start with A. Now if it starts with A, we are having 4 more places. And we are left with 4 distinct alphabets which are 1A, 1K, L and T. So they can arrange among themselves in factorial 4 different ways. After that, after A, it will take the word K. Is it clear? After A, alphabetically it will take K. So now we are again left with 4 places. But here, now 2 A's are available. So these 4 places will be arranged in factorial 4 divided by factorial 2 different ways. After K, L will come. L will come. So L will go. Now it will start alphabetically with A. And we are left with 3 places. 3 places we are left with, and we are left with 3 alphabets, which are A, K and T. These 3 are distinct alphabets. So they can arrange among themselves in factorial 3 different ways. After A, it will start with, alphabetically, it will start with K. So the moment K comes, stop it. Then alphabetically it will start with A. And after A, because we are getting K-O-L-K-A, but alphabetically again it will start with A. And we are left with 1 place which can be filled in 1 different way. Then K-A, after completing with A, it will start alphabetically with T. The moment T comes, cancel this. So the next alphabetical alphabet will be A. So A will come here. So we are getting your Kolkata, which is again 1. Is it clear to all? Is this clear? It's same. It's simple. Only if you compare with the previous sum, there was no repetition. So that is why divided by any factorial was not applied in the previous sum. But in this case, since repeated words are taking place, because repeated alphabets are there in the word Kolkata. So naturally we have to divide it with that number of factorials, the number of alphabets which are repeated in the word Kolkata, like 2 A's. So we have to divide it by factorial 2. But when 2 A's are available to us, if 1 A is fixed, you cannot divide it by factorial 2. Why? Because 1 A is fixed. So only 1 A is available to us. So we cannot divide it by factorial 2. Are you getting the point what I'm saying? Okay. So the rank of the word Kolkata will be factorial 6, that is 720 divided by 2, that gives us 360. Factorial 5 is 120. This is coming to 60. This is coming to 60. This is coming to 24. This is again 12. This is 6 and this is 2. 1 plus 1 is 2. So what will be the rank? 360, 120, that is coming to 480 and 60, 540 plus 60, that will give us 600, 600, 36, 36, 42 and 44. Therefore, it is 644. Is it clear? Therefore, the rank of the word Kolkata is 644. Is it clear? So this is the analytical method that I have done. Now I am going to solve the same sum by shortcut method. Okay? So see the shortcut. This method, this shortcut method will be applied for any word when you have to find out the rank of that word, but when alphabets are repeated, in that case. What you will write? You simply write Kolkata. Now I have to assign a number to each of these alphabets, but alphabetically. So first A will come and there are 2 A's. Therefore, both of this I will write it as 1 and 1. After that K is coming. So it will be 2. This is also 2. After that L will come, which is your 3. After that O will come, which is your 4. And then your T will come. So that will give us, oh, I have written 1 T extra. Let me just erase this. So this will be mine. The number 5 will be assigned to T. Okay, is it clear? Now what you have to do, the same thing that we have done in the previous sum. I have to check how many numbers are there in the right hand side which are less than 2. We can easily see that there are 2 such numbers, 1 and 1. So you simply write down 2. Okay, but now these 2 1s are identical. So it has to be divided by factorial 2. At the same time, this 2 and this 2, they are also the same number. If the same number comes, you must divide the result with the total numbers of that repetition occurs. Is it clear? Here when we are considering k, the number assigned is 2, and again we are having 2 in the right hand side. So it will be divided by factorial 2 again. Getting my point? In this shortcut you have to remember in this way. Then for the alphabet O, it is the number assigned to it is 4. How many numbers are there in the right hand side which are less than 4? We are having 4 such numbers. One is 3, 2, 1 and 1. So it will be factorial. So it will be 4 divided by only 2 ones are there, right? So divided by factorial 2. Then we are considering number 3. That is the alphabet L. Now how many alphabets are there in the right hand side whose number assigned to it is less than 3? There are 3 such numbers. There are 3 such numbers. So it is 3 divided by 2 ones are identical. So divided by factorial 2. Is it clear? Now we are considering the alphabet K. The number which is assigned to it is 2. So how many numbers are there which are less than 2? Only 2 numbers are there and both are identical. So it will be divided by factorial 2. Then you consider the alphabet A. How many alphabets are there? I mean the number are there which are less than 1. Nothing. But it will be divided by factorial 2. Why? Because 1 and 1. I am considering this A. So the number assigned to this A is 1. And we are having 1 again at this side. So it has to be divided by factorial 2. But there is no number which is less than 1. That is why I have considered that thing as 0. Then we will consider T. And the number assigned to it is 5. And how many numbers which are less than 5 are there in the right hand side? Only 1. So we will write this thing as 1. Okay. Now consider the last alphabet which is A. And the number assigned to it is 1. And there is no number in the right hand side. So you simply write 0. Is this much clear to all of you? Absolutely no doubt about it. Okay. Now what I will do, I will write in the same way factorial 0, factorial 1, factorial 2, factorial 3, factorial 4, factorial 5 and factorial 6. Now I will simply multiply this with this and add all those terms. So in the first case we are going to have how much? It is 2 divided by factorial 2 into factorial 2. So let me just do the calculation over here. It's 2 divided by 4 into 720. So we are actually getting, if I cancel this, we are having 180. 180 into 2 gives us 360, right? Now the second calculation, multiply this with this. What you are getting? 4 by factorial 2, that is 2, into factorial 5 is 120. So we are basically having 60 over here. So it is 240. Then 3 by factorial 2 into factorial 4. Factorial 4 is 24 divided by 2. That is 12. So it is 36. Then you multiply this with this. What we are getting? 2 by factorial 2. That is 1. Factorial 3 is 6. So write down. Then this is 0 by factorial 2, which gives us 0 actually. Multiplied with factorial 2 gives us 0. This is 1. And this is again 0. So the total number that we are getting, 360 plus 240, that is 600. Plus 36 plus 6, that is 42, plus 1 is 43. So it is coming to 643. But what I told you, that whatever answer you are getting, you have to add 1 to get the rank of the word given. So in this case, what I will do, I will simply add 1 to get the rank of the word Kolkata, which is 644. Is this clear to all of you? Have you understood the shortcut method of finding out the rank of those words which are having some alphabets which are repeated? Clear? So two things we have learned. When the alphabets are not repeated, we have shown you the analytical method. At the same time, I have shown you the shortcut method. And now in this case, when the alphabets are repeated, in that case also I have done it by analytical method to understand actually what is happening. Now I have given you the shortcut method of finding out the rank of the word in which alphabets are repeated. Is it clear? Now let me take another problem. The question is, if all the permutations of the letters of the word again be arranged in a dictionary, find the 50th word. So what's the question? In this question, they have not asked you that what is the rank of again. No, they have said you have arranged by taking all the alphabets of the word again, and now you are placing those words in the dictionary. So I want to find out what will be the 50th word. That's it. Is it clear? Okay, so let me write again first alphabetically. It's first A, G, then I, then N. Okay? Now, the word that will start with A, because alphabetically it will start with A. Now we are having 4 places and 4 alphabets. So they can arrange among themselves in factorial 4 different ways. So that is coming to 24 words. So 24 words, they are now, already we have put those 24 words in the dictionary, one by one, right? Alphabetically, because it has all started with A. So that will come in the first place. Now, the word next will start with G. And the 4 places will be filled by factorial 4 divided by factorial 2. Why? Because there are 2 A's. So these 4 places can be filled in 24 divided by 2, that is 12 different ways. Is it clear? So total 24 plus 12, that gives us 36. So 36 words, it all came in the dictionary. We have to reach the 50th word. Okay. Next, alphabetically, it will start with I. And we are left with 4 places, out of which 2 A's are identical. So the total number of words that will be formed is factorial 4 by factorial 2, which again gives us 12. That is, till now we got 48 words which are already placed in the dictionary. Now we should be very careful. Alphabetically now it will start with N. And then alphabetically A, G, I will come, right? So this is my one word. That is, we got till 49 word. Now the next word is the 50th word that we want to know. So now alphabetically N, A is there. So after G, alphabetically I will come. And then G will come. Is it clear? And this will be number 1, that gives us the 50th word. Is it clear? So the 50th word will be N-A-A-I-G. Is it clear to all? Absolutely. So I hope now your this dictionary wala problem, the rank problem, is now clear to everyone, right? So that's the answer, N-A-A-I-G, that is our 50th word. Okay? Well, so that's it for this tutorial. We will meet very soon in our next class. Till then, don't forget to subscribe, like and share with your friends, which is at no cost. So till then, see you, goodbye, and take care of yourself.